Good afternoon and welcome everybody to this online event organized by the Swedish Australian Chamber of Commerce Sustainability Committee on hydrogen. What is hydrogen and why hydrogen and how it's produced and applications today. So my name is Camilla Jennings and I work as a general manager for the Swedish Australian Chamber of Commerce. I'm just showing this slide here for everybody to see who is part of our sustainability committee. Let me then introduce our moderator for today, which is Linda Nordin. And Linda Nordin is a circular economy specialist and works as a senior associate engineer, waste and resource recovery at SMEC. Linda, over to you.
Yes, thank you, Camilla. That's correct. That is my title, and I'm going to be your moderator here today. So I thought I would just share with you a little bit about my own interest in hydrogen before we start. So my own interest comes from the work that I have done and undertaken in diverting food waste from landfills and creating circular economies around organics. And one of the ways that you can do that is to produce biogas from biomass, such as food waste, biosolids, and also green waste to some extent, and then turning this into renewable energy or renewable fuel options that you can run, for example, waste collection fleets or other local transportation on. And recently, when I've undertaken these feasibility studies, and for example, last year, it's more common that the councils and local governments are asking, what about hydrogen? Can hydrogen be an option? And where does it fit into this this circular economy? And I think it's a great question and something that we've been starting to look into. And this type of hydrogen would also be a green type of hydrogen that is being produced. So I can see that hydrogen will play an important part in creating a circular economy for the future sustainable cities. And I also think it's likely to play a big part in delivering a climate positive Olympics in Brisbane for 2032, which is very close to where I live. I'm based on the Gold Coast. So I'm honored to be here today, and I'm excited to guide you through today's presentations on hydrogen. And unfortunately, we have to tell you that our speaker from ABB, Hannah, she has become unwell today and is not able to undertake her presentation today. But she will be uploading her presentation and her notes for all of you that have registered, so you will be able to read her content later on. We do have two other experienced speakers with us here today, and that is going to here to start the journey for us and set the scene around hydrogen. His name is Govindaraj NARALASETTI. He's a director in energy and industrial for Surbana Jurong Infrastructure. He's responsible for LNG, hydrogen, ammonia, and decarbonization businesses. And he is a chartered manager and engineer with 23 years of experience in hydrogen production, storage, export solutions, and he will help us to set the scene and also cover some of the aspects that Hannah was going to talk about today. After that, we will have Mitchell Peden, who is a general manager at Volvo Bus Australia and New Zealand, and he has an extensive and long experience in the heavy-duty transport industry. He will apply his big picture vision and close the loop for us today by talking about who and how we will apply hydrogen as a renewable fuel, and what type of end applications that he thinks are most suitable for the Australian market and in general. So if we can just have a look at the agenda, and then we were going to get started. But Camilla, can you say, has Govindaraj managed to connect?
Oh, here we go.
Yes, Linda, I'm in here. Yeah.
You are in. Okay, excellent. Wonderful. I have just introduced you, and so if you could start sharing your presentation, you will, as I said, start by setting the scene and also cover some of the topics, as we couldn't have Hannah here from ABB today, unfortunately. And if there are any questions, please put them through the chat, but there will also be possibilities to ask your questions live at the end of this session where we will run a Q&A.
Good morning and good afternoon and good evening from the people where, where you are connecting for this webinar. I'm Govindaraj. I'm the Director of Energy and Industrial within Surbana Jurong. So I will take you through today's discussion, what is hydrogen and why hydrogen, and what are the types of hydrogen in this webinar. Sorry, my camera has got some technical glitch, so unfortunately I could not switch on because of that. Okay, let me take through the agenda. So why hydrogen? So I will briefly touch base on the climate change initiatives, COP 2026. And we can go through what is hydrogen and what is the hydrogen demand, how the hydrogen has been classified, the classification such as green, blue, and gray hydrogen. What is a typical sustainable supply chain of hydrogen, which is a green hydrogen. I will touch base on it. And then hydrogen production, production. What are the production mechanisms? How the hydrogen will be produced? What are the challenges currently this industry is facing in terms of hydrogen production, storage, transportation, and usage? I will end up with a quick case study of a 100 megawatt power plant, which is, and I will also give you a comparison between LNG and liquid hydrogen in terms of storage and, in terms of flow rates and so on. And last but not the least, I will be also touching base on the process safety aspects of hydrogen. Moving forward, actually in COP 2026 goals, so these are the 4 major items which are being discussed and agreed globally. Secure global net zero by mid of the century by 2050, and keep the rise of temperature to 1.5 degrees, which is within reach. So some of the suggestions which were given at that time was, phase out the coal, curtail the deforestation, switch to electric vehicles, and invest in renewables. Number 2 is adapt to protecting the communities and natural habitats. For example, protect and restore the ecosystems, build defenses, or you can avoid loss of homes because of heavy rains, livelihoods, and so on. Third one is important, which is mobilize finance, which is a green financing. So developed countries has committed to mobilize at least $100 billion where for the other countries who intend to actually start some green solutions. Number 4 is work together to deliver. That is also finalize the Paris rulebook, accelerate the actions to tackle the climate crisis through the collaboration. These are the 4 items which were discussed. Moving forward, so if you see the hydrogen by hydrogen, and you can see that most of the energy is consumed by industries, and within the industries, and followed by sorry, one second. Okay. Most of the CO2 is generated from industries, basically, and then also a little bit from the agriculture, which is also significant amount of CO2 is being generated from agriculture side as well. If we leave the problem like this, what happens is CO2 generation will be keep on increasing, and by 2050 we will be in a position to reach up to 50 gigatons per gigatons of CO2 equivalent, which is quite which will exceed the 1.5 degree temperature rise where we are targeting for. So hence we need to be below that. So what we need to do is we have to take more greener options to lower the CO2 emissions. How can we do that? We can reduce the dependence on the fossil fuels, shift to zero carbon source, mainly, for example, solar, wind, batteries, and so on. We can also use energy efficient technologies, minimize the use of energy. Basically, you can optimize the use For example, nowadays people carry a couple of two, cell phones. Instead of that, you can carry one. So we have to be using the energy more diligently. Then, we can also use the carbon capture and storage solutions to overcome the problem. Okay, next is what is hydrogen? Hydrogen is a colorless, odorless, and non-toxic, which is abundantly available on the Earth. It only emits water when it is combusted, and it needs to be cooled down to minus 253 degrees C at atmospheric pressure to liquefy it. So typically, hydrogen has got a high energy density when compared to LNG, LPG, and even coal. But however, what does it mean is because it is very light, so you need much more higher volumetric flows to be utilized to achieve the same amount of power production. So hydrogen demand, mainly hydrogen demand is, I have classified that into 4 different sectors. One is transportation, which Michelle will be talking about it. And then second one is chemical and industrial applications, stationary and power generation applications, and then integrated hybrid energy systems. So mainly you can see that which are the areas which will be driving these needs. For example, if you take in the chemicals and the industrial applications, the cement and the steel industries are bound to take it. Industrial heat and biosynthetic fuels. And then you can also look into from the power generation side, we can see the hydrogen combustion and reversible fuel cells. All these things are coming up. Then you can also look into the integrated or hybrid energy systems. So it is basically the nuclear or hydrogen hybrid, which can give you a much more greener solution. And then hydrogen blending into natural gas systems and so on. You can see in 2015, this is the demand projection given by Global Hydrogen Council. Basically, initially it was around 8 exajoules, which is 10 power 18. So it is expected that the consumption will increase from 2015 to 2050, almost roughly around 9 times, more than 9 times. Yeah. So this is the classification for hydrogen. Hydrogen is broadly classified into 3 types of hydrogen. The bottom one where you see this one is a gray hydrogen. In the gray hydrogen, it is, the source of raw material is the fossil fuels, and then we use the non-renewable energy and processes like, reforming, gasification, that generates the hydrogen and also CO2. Apart from that, second one is the blue hydrogen. In the blue hydrogen is the hydrogen which is generated by capturing the carbon CO2. So what it means is the gray hydrogen plus carbon capture is nothing but your blue hydrogen. Green hydrogen is nothing but you will be using the raw materials like biomass, water, and renewable energies like solar, wind, or tidal. So that is the type of the energies which we'll be using, and we'll be using the processes such as electrolysis or biogasification processes to generate hydrogen. This is typically, it doesn't have any CO2 footprint at all. So this is the typical value chain of hydrogen. It starts with the primary renewable source like wind, solar, tidal, biomass, and so on. Then we have processes such as electrolysis or coal gasification with a carbon capture will be giving a green hydrogen. Then hydrogen storage, which is whatever is the hydrogen which you have generated, we can store it as a product, which is a liquid hydrogen or a compressed hydrogen. Or we can also generate ammonia or LOHC, or even we can look into absorption on solids. And the fourth one is hydrogen transport. Hydrogen can also be utilized for hydrogen transport challenges. Hydrogen transport, which is a liquid hydrogen, which will be carried using ships, tankers, trucks, and pipelines. The last one is hydrogen use, which is a power generation. Hydrogen can be utilized for your power generation, ammonia production, synthetic fuels, or marine fuels, and so on. So if you see the current hydrogen production trends, it is mainly developed from SMR, which is and also naphtha refining. and you will see some percentage from coal gasification and very little on electrolysis. But for us to move from to a green hydrogen, the green part, what you are seeing here, which is an electrolysis, need to be a bigger one. So this is also one of the data which I picked up from an IEA. This is where you will see that the cost of hydrogen production when you are using a power from a grid, the cost of hydrogen can be almost nearly $5 per kg of hydrogen. And when you are using a renewable energy, it can be lowered nearly to 3. And when you are using natural gas without CCS, it's also around 2.5 or 2.2. Then with natural gas and with CCS, it's slightly nearly to $2.5. So this is all again depends upon location and where you want to put this plant. There's quite a lot of factors associated with it. Here is the differences between blue hydrogen and a green hydrogen. You can see that by 2030, people are expecting that most of the hydrogen source will be almost more than half will be from blue hydrogen, whereas the green hydrogen tend to start and increase. And by 2030, the blue hydrogen is also almost 3 times. This is first one is a planned scenario. The second one is a transforming scenario. That means this is more optimistic, and this is a pessimistic scenario. So here you can see that it can go as big as 3-fold, and even the green energy started building up. By 2050, the pessimistic scenario is it will be staying at the same level, but there will be a slight increase in terms of blue hydrogen. But whereas the optimistic is the green hydrogen can potentially go to almost 6-7 times than the planned scenario. Green hydrogen is mainly coming out from the electrolysis of water, which is electrolysis of water or also biomass or waste gasification. Whereas the blue hydrogen is coming from natural gas conversion with CCUS or coal gasification with CCUS. What are the key challenges? Currently, the hydrogen technology, in terms of like storage or so, it is quite a lot of challenges are being faced, because you can see that the storage tank sizes are limited to 2,000 to 10,000 meter cube only. That is because of vendors are not available still to produce the scale like equivalent to LNG, which is around 180,000 scale. Okay, then we have hydrogen transport challenges. This one also the same thing. The ships to carry such a huge amount of hydrogen are not still in place. There is a very quite small amounts are being transported from Australia to Japan currently, and we foresee that there's still around 5 to 10 years to come to the level where large volumes will be transported in a bigger scale. So quickly to summarize, basically hydrogen uses, hydrogen can be utilized for power generation in CCGTs, basically. So the technologies of the CCGTs using the 100% hydrogen is being tested now, and it will be commercially available from 2025-26 onwards from various vendors. Then we are also looking at a fuel cells for the vehicles. Here, this one is also, although, the technology is quite mature, but still, the capex and the footprint and all still are some of the challenges for the vehicles. Maritime side, still we see that, the hydrogen, the cost of hydrogen is quite high because of the, high cost of hydrogen. Even maritime is not, quickly coming up to put this type of solutions. And even for the for the storage and transportation also, it is quite challenging. A quick case study we have done. We have done a quick 100 megawatt power plant, in which we looked into the jetty infrastructure required for that, and also the storage requirements, and recirculation, and high pressure pumps, and vaporization, and cold energy harnessing is also being looked at, and then CCGT, which are actually powering up to green data centers. This is a project we have conceptualized. And we feel that although the CapEx from a CapEx wise is quite significantly higher when compared to others, but the infrastructure requirements of hydrogen is also quite different than an LNG. So this picture will give us, in terms of how the mass flow requirements for 100 megawatt power plant. So the green one is for the hydrogen, and the red one is for natural gas. If you see the volumetric flow of a hydrogen required is almost like 2.5 times the LNG, so natural gas. And the storage volumes required to achieve the same 100 megawatt via hydrogen, you require quite a substantial storage, which is almost twice the LNG. And then the cold available with liquid hydrogen is quite higher than LNG, because you can actually, because of the very low temperature of minus 256 degrees C. This will give us a good idea. So let us say one ship of LNG carrier of 160,000 meter cube, if I take it. So then you can, this is equivalent to 2.5 ships roughly of LH2, liquid hydrogen. If we are actually comparing the energy equivalent to one ship of LNG, and then this is also equivalent to 1.67 times of 1.75 ships of ammonia. This is an equivalent comparison. Process safety considerations. So we believe that hydrogen comes with quite a lot of process safety issues. So it is a very highly flammable, but it burns with an invisible flame. It has got a wide range of flammability. It can explode between 4% to 74%. It's quite a wide range when compared to natural gas of 5 to 15. We need to ensure that wherever you are storing and handling, you need a adequate ventilation. You need to also ensure that we have a right purging requirements, like helium gas is recommended over nitrogen. So we will be, like, for example, for any refinery or natural gas plants, we will be using as a fuel gas, as a natural gas, or nitrogen for purging. But here you need helium. Then, what are the hazards associated with hydrogen? Are fire hazard, explosion, asphyxiation, and also the cold burns because of very, very low temperature. So the most effective and efficient way to fight hydrogen is we have to ensure that the facility is designed inherently safe to shut off the flow of the gas. Use a dry chemical powder to extinguish the fire. We have also looked at dispersion analysis. We have done with a 10 mm leak, 25 mm leak, 75 mm leak to see that what is the safety distances or the safety HSSC buffer zones you need to maintain. So we see that it can go as low as 2 meters to 120 meters. So it's almost similar to LNG, because hydrogen being quite lighter, it is basically, we are seeing that the flow is going vertically upwards. Yeah, thank you. I will be taking the questions if you have any later. Thank you. Thanks, Linda.
Thank you so much for that. That's very interesting, and it tells the story really around the whole supply chain of hydrogen. And we'll take questions later. We'll continue with Mitch, who will now talk us through the end applications within the heavy duty transport sector and the buses. Welcome, Mitch.
Thanks, Linda. I hope you can hear me, and thanks, Camilla, also, and Raj. Good information there, Raj. Thank you very much. I'll quickly touch on hydrogen as a renewable fuel option within our group, the Volvo Group. I'll quickly share what we're about. Obviously, some of the divisions within our company, and I guess the shared intent around the divisions of our organisation to build capability in this area, in the hydrogen fuel cell area, which is very exciting. I can make this work. Here we go. So what we do, our organisation is various business streams: construction equipment, the truck part of our business, Volvo buses, and also the Peden marine side of our business as well. The car company, some of you may be aware, some may not, is not part of our organisation any further, although we do have some joint development programs that happen, particularly around the safety side of things, in line with our safety core value. In Australia, our brands, Volvo truck, Volvo construction equipment, Volvo bus, as I mentioned, the Peden marine industrial engine side of things. And we also have the UD Japanese truck brand within our portfolio, and also the Mack truck brand as well within our portfolio also. And all divisions are currently moving with their innovation roadmap through to zero emission vehicles, through both electric, battery electric, and into hydrogen fuel cell as well for different and varied applications. We've got pretty ambitious targets in our company, kind of to a degree lined up with what Raj just outlined earlier, but 50% reduction in CO2 emissions by 2030, 100% by 2040, and as an organisation, net zero by 2050 compared to our 2019 figures, which is very ambitious for us, being a commercial vehicle producer, but certainly well on our way to hitting these numbers, which is fabulous. As I mentioned earlier, across our business units, we do have common architecture and shared technology. So when we do talk about moving from our internal combustion engines through to battery electric and then into hydrogen, this is being developed across our business units for varied applications as we start to understand the parts of our business that will require this technology, and our operators and customers that will require this technology to meet their needs and their customers' needs, and the parts that will be well catered for by the battery solution. But certainly hydrogen and the fuel cell technology is going to play a strong part in our business as we go forward. We're not a latecomer to the I guess zero emission electric vehicle space, kicking off in 1995 with concept trucks and buses, through to production start of electric buses and trucks through to in 2022. But I'll touch on our roadmap journey shortly into the hydrogen and fuel cell side of things. As far as the truck side of things goes, and our buses can be plotted here as well to a large degree. It's really the battery electric will cater for the bulk of what we are needing to do in the refuse space, city regional distribution, urban construction. But as far as the inter-regional haul goes, heavy transport, heavy line haul, the longer distances, the limited access to infrastructure for recharging and refueling, we certainly see the fuel cell electric vehicle playing a very strong part there for our organisation. And we also see potential down the road as well for hydrogen to also be used potentially in internal combustion engines as well for extremely heavy duty applications down the road. Where I guess heat and weight aren't your friend when you're trying to package up, I guess, the hydrogen fuel cell tanks and infrastructure onto a chassis to meet the particular needs. So we also see internal combustion continue to play a part hand in hand with new technologies around hydrogen as well. But this is a basic, I guess, overview of where we see it, our planning and our requirements as we go forward in the long haul inter-regional heavy transport space. We can't package enough batteries on our trucks for interstate transport. It just makes them far too heavy. They won't meet ADR requirements, and they won't carry much of the goods that we need to be carried around the country. So really it's the fuel cell vehicles that are really coming into play now and into mind. We project that in that greater than 76 tonne mark, we'll be able to deliver a prime mover onto Australian roads that can go around that 800 kilometres distance, which is going to be around where the requirement's going to be for that interstate, intrastate type operations, which is really where the sweet spot's going to be, that East Coast line haul and that B double running, and all the other operations around that as well, milk cartage and the like as outlined here. Here is an image of a fuel cell prototype in Europe, which we're currently running in test. We don't get to see it much. We haven't got anything in Australia as yet, but certainly we are full noise with regards to not only full testing, but fuel testing, range testing, safety testing, and all the good things that we need to do. Cold weather testing, hot weather testing, and all the different variations to put out a product in line with our quality core value, but also in line with our safety core values and in line with the expectations of operators of having a product that will be as good, if not better, than previous generations of products that we've put onto the market, where operators can go and start to grow their businesses to scale and with many vehicles, and not being concerned around some of the safety challenges that we heard outlined a little earlier, let's say, in Raj's presentation. Fuel cell electric, I think Raj touched on this pretty well, but obviously it's a very highly complex fuel cell system. Tanks on board the vehicle, they are extremely high pressure. Our organisation, my understanding is that we are working on some lower pressure applications to take away some of the complexity, but absolutely extra cooling is required on the vehicles to make sure that we're able to keep these gases stable and keep it as safe as can be made possible, let's say. We also have to be very conscious of fast refuelling. I guess the range required of operators if they're going to be covering the vast distances in Australia, and also the heat around long range transport as well. That's our cross to bear in Australia, the significant heat burden that our temperature and our operators have to contend with. But it's obviously very important that we get this right. Limited fueling infrastructure at the moment is a challenge. We see that over the course of the next decade, obviously with new investors coming into play, government intent to be able to build this capability, we see that being, I guess, met in the medium term. These vehicles are at the moment, though, at quite a high price point, so it will be over the course of time as well. When we start building at scale, we start to get those economies of scale benefits and start to bring, I guess, vehicles onto the road at price points that are viable. And also, we need to be addressing any safety concerns as well. It's a highly flammable gas, obviously requires extremely careful handling to ensure those safe outcomes as we move forward, which our operators and business partners will always expect of Volvo. It's extremely exciting, though. It's highly expensive to be developing these technologies for a global market. So Volvo has joined forces with another heavy automotive behemoth, the Daimler Group. I'm sure you're all aware of. We've joined forces for an organisation that we are joint owners of, 50-50, called Cellcentric. It's based in Germany, and our joint venture is, for both of our organisations, accelerating development and commercialisation of the hydrogen and fuel cell systems for use in heavy trucks, the buses, marine applications, stationary applications, and all other manner of different things, which is extremely exciting for our organisation. We are seeing more and more now large organisations like Volvo and Daimler, as an example, sharing development costs. It is quite prohibitive to be developing multiple different new technologies at the same time, and both companies are also working on their battery electric technologies as well to deploy across the globe. So making these sharing arrangements, it becomes quite interesting, and it's at the moment, as it's rolling out through Europe, it's also quite strategically important for us as well. This joint venture also will be tackling the infrastructure and refueling infrastructure as well through Europe. We haven't had plans yet around what that might look like in Australia, around any investments from our groups in that space. But that said, obviously, to drive towards and hit our targets, we need to make sure that our operators and partners are able to access the fuels as well as we go forward. But it's extremely interesting, and it certainly is proving to be a highly viable alternative to traditional fossil fuels. And we do see this joint venture contributing to the development of not only safe, sustainable, high-quality product, but also contributing to developing the network as well for the refueling, as I mentioned. And of course, why? It's really contingent on organisations like ours. We've been part of the problem for a long time with regards to mass heavy-duty diesel engines and vehicles on the road. So it's really contingent on companies like ours being part of the solution as well, obviously, for the future generation challenge. It's a highly competitive space at the moment, as we all appreciate. But it's if you like competition and you enjoy seeing the evolution of the industry, it's a fascinating place to be part of at the moment, which is excellent. So I'll hand back to Linda, but obviously we're looking to enjoy any questions anyone might have. So thanks for taking time to listen. Cheers.
Thank you so much. Really interesting perspective there on how hydrogen can actually form part of our society. And anyone who would like to ask a question, please do so. I might just start with, I had a question. We were listening to the different types of hydrogen that are being produced. And one of the things that you hear about is that it's not yet financially viable to produce the green hydrogen. And the question is it still a sustainable option for our environment to use hydrogen if it's not green hydrogen? Govindaraj, perhaps would be, yeah.
Thank you. Actually, see, hydrogen is definitely a choice for us to go green, definitely, right? So now the source of hydrogen, when it is a green hydrogen, it is 100% green. That means, whereas, if it is a blue hydrogen, it is partially green. So it is when we are in the decarbonization journey, I believe that a blue hydrogen is the one which will be available much more, in a shorter term. And it's a way forward for it. Actually, that will help the industries to start using the hydrogen as well.
So to sort of transition over, like you were showing as well in your graphs, eventually over to more green hydrogen. Yeah. Mitch, do you have anything else that you would like to say on that?
No, Stuart, really, it's obviously the aspiration and the large conversation is going to be around green hydrogen. It seems to be really resonating around, you want to have the gold medal fuel, let's say, if you're going to be doing it at all. But at the end of the day, I do believe, though, that it's going to come down to cost benefit. It will come down to different applications and what's going to enable, I guess, operators and to be able to move forward in a cost-effective way, let's say. We don't want to have to see operators looking to try and pass down their costs in a way that doesn't make transport viable. So at the end of the day, it's really going to come down to what ways can we enable incremental steps towards zero-emission vehicles without having to be perfect straight off the bat, I would think. But we can always aspire to get to the gold standard down the road, I would say.
Yes, and I know that also for everyone who's listening to, you can read a little bit about the slides that Hannah was going to talk about. I think she has also got some information around green hydrogen and the financial viability there. Now, is there anyone that would like that are attending that would like to ask a question? I have more questions, but if anyone else out there would like to ask one, you can just sort of put your video on and then ask the question if you like. Give you a few seconds. No? Okay, well, I have another question, and it is, so you both sort of talked and touched on some of the hurdles around producing hydrogen. If you had to just choose one or two, what would be the main hurdles or the main key success factors to actually produce hydrogen in a financially viable way? And let's start with Govindaraj or with Raj.
Yeah. Thanks, Linda. See, currently when I showed in my presentation, right, there are two major challenges for hydrogen. One is the technological, development. That technology is growing now to handle higher volumes of hydrogen. So if you see, NASA is using hydrogen for a longer time for aerospace, right, space-related activities, right? So, but the volume is very little. Right, they have a small volumes. But what we are now trying to bring hydrogen to be utilized as a source of energy for producing electricity and running vehicles and all, which requires quite a lot abundant use, right? So this is where I believe the technology is still in transition and people are testing their own technologies. It might take 5 to 10 years. That is one thing. Second is while it is coming up like that, the materials are expensive because you have to use exotic materials for storing liquid hydrogen at minus 253 and so. So and everything is going to be expensive. I believe that even at the end user side, the capability of paying high should also come up equally. Then only you will see that it will be moving faster than ever.
Yeah. Do have another question for you, actually, what can take immediately, and that is because we were talking about different types of applications and end applications, and perhaps you could just share and clarify from your perspective as well. You were saying you have prototypes that you've started and they are in Europe at the moment, but when do you think we will actually see these end application as more of a mainstream in Australia?
It is interesting. Obviously, there's a number of new market entrants into Australia that are deploying these technologies now. It does interest me that I guess global companies like Volvo and Daimler would have the scope and capability to go and buy these companies and technologies, let's say, and assume them and deploy them. I guess if I speak from Volvo's perspective, with safety and quality, and I guess make sure operators have, I guess, an asset life that is makes their business viable is so important to us. We're estimating that full development and testing of these new products from our group will likely be taking us through to that 2025-26 sort of mark, where we expect really around probably 2030 to be a point where hydrogen fuel cells are being deployed in a mass, high quality, highly safe product range across our organisation, and in a way that will be confident that we will have, I guess, a product range that will be able to stand up and handle the rigours of the various market conditions, not only in Australia, but in the various market conditions around the world, let's say. So, because it's, as I said, it's highly complex. They're very expensive at the moment. At the end of the day, uptime of vehicles is so important. We just need to make sure that we've got our testing done. It does take a long time to get that testing programs in place. So there's no point trying to sugarcoat it. It's coming imminently, because it's just not. But when we are ready, we'll be confident we'll have a product that will be very productive and very viable. So
And you mentioned something. I'm not sure if you've actually got the solution on that yet, but you were saying, you're struggling here in Australia with the heat that is produced from hydrogen. How do you actually get around that? Is there a solution yet?
Well, it's always a challenge. It's been a challenge for us since we started making vehicles here in the early 70s, just to get enough cooling on our heavy trucks to keep the vehicles cool enough to be productive and to not have quality issues. Obviously, that challenge will extend through to hydrogen fuel cell vehicles. We'll be working with putting the latest cooling technologies onto the vehicles. But at the end of the day, some of these infrastructure is often large and it's often heavy. So at the end of the day, it's also about keeping vehicles in line with the weight restrictions over the front axles, the weight restrictions that you're allowed to run in a heavy vehicle, and also putting onto the road a productive vehicle that our operators are able to put enough load onto it. Let's say that they'll be productive vehicles. So it's a bit of a cost benefit, let's say, as we always try and pull weight off our vehicles. But at the end of the day, we need to make sure that we've got a quality outcome at the end of it.
Okay, we actually have a question here now from Flavia.
Thanks, Linda. I guess, not being new to the topic, it'd be great to understand what's, generally the industry view and government view around hydrogen as the gold standard or the next level that we need to get into, because it seems like there are some challenges, not just companies adopting it, cost, but also the entire supply chain, and there needs to be improvements made and all of that. What's your view on, or can you share with us what the government, how the government is looking into it, and what general industry views are?
From Volvo's perspective, government is across all the state governments that we have interaction with, and federal as well, extremely interested in the potential of hydrogen for the transport sector. It's certainly seen as a potential enabler, let's say, of reducing our emissions, which is fabulous. That said, I think everyone's still getting their head around the cost of the assets, and also I think as well, like being able to put a vehicle on the road and demonstrate it, in front of a media group is one thing. Being able to put a vehicle on the road that's going to do its 200,000 kilometres a year in, year out for 5, 6, 7 years sort of thing with a productive uptime is another thing altogether, let's say. So there's currently a lot of good energy around the potential of hydrogen, but I guess we just need to have a bit of patience, let's say, while I guess organisations are able to bring products to market that are going to be viable and are going to be able to drive quality outcomes. There's no point organisations spending upwards of let's say $1 million on an asset if it's not going to be able to be used regularly, let's say, because you wouldn't do it again if you did it once. So you want to make sure you've got, I guess, high quality, tested and safe assets if you're going to be looking to put them into your business at scale, let's say. So, but the potential is there. Everyone's beavering away to try and find the sweet spot with that, which is great. So.
We actually have one more question here also from the audience, from Fredrik. And he's asking, thanks for good presentations. Do you both think that infrastructure for hydrogen supply is going to be built out in the same pace as the roadmap for the vehicle technology development?
I'll start with that one potentially. I do cast my mind back to when diesel fuel vehicles and heavy duty vehicles had to put on AdBlue, if you remember, the urea into the diesel engine. It was a classic chicken and egg scenario. The large refuelers wouldn't invest in the stations until there was enough vehicles on the road to make it viable, and the vehicles need need the liquids, let's say. So it's going to be, I think government will need to get involved, let's say, and have some kind of motivational investment type programs to enable, I guess, the investment in these infrastructure assets, because they are going to be expensive. We need a lot of them, and to have operators start moving forward with confidence. This is what's going to be. They're going to need to be able to see this happening, let's say, before they're going to. Otherwise, you wouldn't put your toe in the water with it, I wouldn't think. So, it is interesting, but it is going to be a bit of a slow burn, I think.
Maybe, Linda, I will also add a couple of sentences here, if you allow me.
Yes.
I think, Mish, I totally echo with you on that. The way, there will be an initial support which is required for the infrastructure. So, for example, if you want to utilize hydrogen for power, for power generation, the existing natural gas pipelines are not enough to take the pure hydrogen. So there will be a change in the infrastructure. There will be an infrastructure associated cost, where I think, which I believe that, governments will come in to, spend some initial amount for the infrastructure, and the users who will be connecting to those infrastructure will be, paying on, as per use, basically. Yeah, so there will be definitely a drive from the governments, and we see that. And I myself sit into the hydrogen, council for developing the standards for that. So we see that the things are moving positive, and governments are also sending positive signals to implement hydrogen. So there is a roadmaps which are there, but to answer to that, probably roadmaps may not be followed as per the defined dates. That's where I think the government has a role to push all the stakeholders to make it happen, I guess. Yeah.
Thank you so much. So so the development is not just going to be driven by the fact that hydrogen is a very sustainable alternative for us here, but also needs to get some help from governance and the governments in each country, and here in Australia. Is that correct?
Yeah, rightly said.
Yes. Yep. Okay, well, I think that Mitch and Raj, I would like to thank both of you so much for presenting here today, and everyone that's tuned in to listen. And we would just like to hand over to Flavia, who is our chair for the Swedish Australian Chamber of Commerce Sustainability Committee, to say a few final words and close this out for us. Thank you, everyone.
Thank you, Linda. Thank you, Raj and Mitch, once again, and also to you, Linda, for sharing your passion and walking us through a topic which not many of us, or at least not me, is clued on. Before, I know it's between me and dinner, for those of you in Australia, before we end, just a quick note on upcoming events. We have two that's scheduled in June. One is an event on circularity. We have Dr. Nicole Garofano, who's the head of circular economy development at Planet Arc, to share insights from the World Circular Economy Forum. And then we also have a roundtable that's planned on sustainability in food and beverage. So look out for these events. They are typically listed on the SACC website and also LinkedIn, where members talk about it and share the latest. And with that, thank you once again. And, we hope to see you at our future events and keep engaging on the topic on how to take sustainability to the next level.